When calculating work, use the equation WFD cosine theta.
In this type of problem, what you would use is you've got a specified constant force, so you'd use that value in for F. You have a specified displacement. You would use that value in for D. Then the question is, what would you use for theta? Theta would be the angle between the force and the displacement. We also have units for the work being done. And the units are going to equal the units of force, which are newtons, times the units for displacement, which are meters. But instead of always calling it newtons times meters or newton meters, they came up with a word. They honor the James Joule with the units of work. So the units of work are joules. Okay, so we want to know how much work did the rope do on the box. So I use my work equation. Work equals FD cosine. And to get a better look at what this looks like, I'm going to draw a picture. There's a box, and I know that the rope is being pulled up at that angle, and that angle is given as 20 degrees. So that's a 20-degree angle right there. Now I'm looking for force. The problem says that the force is 130 newtons. And the problem says that there's a distance of 30 meters, so that makes it nice. And then I need cosine. And the cosine that I want is the angle between the force and the displacement. So that is my 20 degrees. It's not always going to be that. You've got to actually go back and look. So we have cosine 20. So when I do the calculations for this, I have 130 times 30, which is 3900. And the cosine of 20 degrees is 0.94. And when I run through the calculations, I get 3,664. And my units for work are joules. Joules. Okay, now here's a question. Why do we have to do this cosine theta piece? So remember, our equation is FD cosine theta. We use cosine theta because the force has to be in the same direction as the displacement if work's going to be done. Well, in our example here, the force was not in the same direction as the displacement. But if I do F cosine theta, remember, cosine gives me the x component of the force. So what that gives me is how much force is in the x. I could do F sine theta to get the y, but I don't want that. So F cosine theta is the x part of the force, giving me the force that is in the same direction as the displacement.